Hello everybody, welcome to our lesson. Today we will solve a problem on the topic motional EMF. And this is the goal of the lesson. At the end of the lesson you will be able to use the equation for the motional EMF. And before we start solving problems, it will be useful to recall the equation for the motional EMF. The motional EMF is equals to the velocity times b and times the length of the conductor. And note that the minus sign don't affect to the magnitude of the EMF. So this is the first problem. First of all, let's write what is given. So EMF, it is given, it is 0.02 volts and the length of the wire is 0.1 meters, and when it's moved perpendicularly across a uniform magnetic field, the speed is 2 meters per second, and we asked to find the magnetic field strength. So let's use the equation for the EMF, and I'm going to find only a magnitude, so I don't need the minus sign here. And E is equals to 0.02 volts and velocity is 2 meters, B we don't know, and the length is 0.1 meters. So 0.002 is equals to B times 0.2, and the answer is 0.002 over 0.2. So we can cancel out here this 2 and 2 and 1 0. So the answer is 0.01. The unit for the magnetic field is Tesla. So let's move to the second problem. So here the same situation, but the conductor is at an angle. So first of all, let's write what is given here. So we know the magnitude of the magnetic field, it is 0.5 newtons per ampere meter. We can say it as Tesla. And the length, it is 0.3 meters, and the velocity, it is 0.8 meters per second, and the angle, it is 30 degrees. And we're asked to find the induced EMF. So when the wire is at an angle, the equation changes. We add a function of the sign, and let's put the givens. Velocity, it is 0.8, field, it is 0.5, length, it is 0.3, and the sign 30 here. So 0.8 to 0.3, it is 0.4, and it is 0.12 if you multiply to 0.3, and sine 30 is 0.5. So the induced EMF is 0.06 volts. Okay, the third problem. So we see here that the wingspan of a Boeing jetliner is 59 meters. The length is 59 meters, and the jetliner has a speed of 720 kilometers per hour, and the magnetic field at that location is 4.5 10 minus 5 Tesla. And this is the perpendicular field, so we don't need an angle. The sign for 90 is 1. So we're asked to find an induced EMF. Again, this is also simple. This is the equation for the induced EMF, and we don't need to write the minus sign. So EMF is equals to velocity. Here, velocity, it is 720 kilometers per hour, and we need to convert it to the meters per second. And this is 200 meters per second. So this is 200, B it is 4.5 10 minus 5, and multiplying to the 59 meters. So let's calculate 200 multiplied to 4.5, it is 900, and multiplied to 59, it is 53,100, and we have a degree, it is 10 minus 5. So now we need to move 5 steps back. 1, 2, 3, 4, 5. So actually we add a 0, and we see the answer is 0.531 volts. So this is the half volts. Now next, the final problem. So here again, let's write the givens. What we have, the resistance, it is 6 ohm, and the length of the conductor, it is 1.2 meters, and we have a uniform magnetic field, it is 2.5 Tesla. Okay, at what speed should the bar be moved to produce a current? We know the current, it is 0.5 amperes in the resistor, and we're asked to find the speed. Okay, first of all, the current through the conductor, it is the EMF over resistance, and we know the EMF, it is V times B times L. So then we can state that current is VBL over R, but we are asked to find the velocity. So that's why velocity will be IR over BL, and that's it. All we need is to put the givens here. I, it is 0.5, and the resistance, it is 6 over field 2.5, and the length is 1.2. So we can cancel this. We have a 5, and 6 over 1.2. We can also cancel, it's also 5. 6 over 1.2. And we have an answer 1 meter per second. So this is the final problem. Okay, this is the end of the lesson. I hope you've enjoyed solving problems with us. If you like our video, please subscribe and share. Thank you.